A car engine is the heart of an automobile, designed to convert one form of energy into mechanical energy. It functions as a heat engine, where fuel is burned to generate heat, which is then used to do work. An engine gets this output through a spark by igniting the mixture of petrol, vapor, and compressed air inside a confined space known as the combustion chamber, or in other words, inside the cylinder. There are two types of engines, the internal combustion engine and the external combustion engine. An internal combustion engine is a heat engine that burns its fuel inside the cylinder. An external combustion engine is an engine that burns fuel outside the cylinder. The engine is the most essential part of an automobile. In this video, we'll take a look at the function and construction of each engine part of an internal combustion engine. The main parts of an internal combustion engine are cylinder block, cylinder head, gasket, manifold, flywheel, oil pan, crankshaft, camshaft, connecting rod, piston, piston ring, piston pin, valve, rod bearing, main bearing, and bearing caps. Let's start with the component and their functions, starting with the cylinder block. The cylinder block is the central structure of the engine and is often made from gray cast iron or aluminum, while the crankcase is attached to its bottom. It houses the cylinders where the piston moves up and down, it holds the crankshaft, and it contains oil and coolant passages for lubrication and temperature control. It also includes main bearings, coolant jackets, oil galleries, and mounting points for the cylinder head and other components like the flywheel, water pump, fuel pump, and the timing gear system. The cylinder head is a vital component of an internal combustion engine, mounted on top of the cylinder block to form the upper part of the combustion chamber. It seals the top of the cylinders, allowing for proper compression and combustion. They are often made of cast iron or aluminum alloy. The cylinder head manages the flow of air-fuel mixture into the engine and exhaust gases out through the intake and exhaust valves. It also holds spark plugs in petrol engines or fuel injectors in diesel engines, which are essential for igniting or delivering fuel into the combustion chamber. Internally, the cylinder head contains coolant passages to help dissipate heat and oil passages for lubricating moving parts. It also supports the entire valve train mechanism, including components like the camshaft in overhead cam engines, valve springs, lifters, and valve guides, all of which work together to open and close the valves with precise timing. The crankcase is the lower part of an internal combustion engine that encloses and supports the crankshaft. It forms the base of the engine and houses the crankshaft in older engine designs. The crankcase contains main bearings that hold the crankshaft in place and allow it to rotate smoothly. It is connected to the oil pan and includes oil passages that distribute oil for lubrication. The crankcase also plays a role in engine ventilation, often using a positive crankcase ventilation system to release pressure and prevent oil leaks. The oil pan, also called the sump, is a metal reservoir attached to the bottom of the crankcase. Its primary function is to store engine oil, which is essential for lubricating moving parts inside the engine. As the engine runs, oil is pumped from the oil pan through various oil passages to lubricate the moving components. The oil pan also helps with cooling the oil, as it is exposed to airflow underneath the vehicle while driving. It has a drain plug that allows for easy removal of old oil during oil changes. The manifolds in an engine are crucial components that manage the flow of air into and out of the engine. There are two main types, the intake manifold and the exhaust manifold. The intake manifold is connected to the throttle body and mounted on the cylinder head. It distributes air or an air-fuel mixture evenly to all the cylinders, ensuring each cylinder receives the right amount for efficient combustion. On the other side, the exhaust manifold is also mounted on the cylinder head, and it's responsible for collecting exhaust gases from each cylinder after combustion and directing them into the exhaust pipe. While the intake manifold is often made from plastic or aluminum for thermal efficiency, the exhaust manifold is typically made from cast iron to withstand high temperatures. A gasket is a flat sealing component used in engines to create a tight seal between two joined surfaces, preventing leaks of fluids or gases. It is typically made from materials like rubber, metal, cork, or composite fibers depending on its location and function. In a car engine, gaskets are placed between key components such as the cylinder head and engine block, intake and exhaust manifolds, crankcase and oil pan, and valve cover. Their main job is to seal off internal passages for oil, coolant, and combustion gases, even under high temperature and pressure. Gaskets also help absorb minor surface imperfections between metal parts, ensuring full contact and preventing leaks. Cylinder liners, also known as cylinder sleeves, are cylindrical metal inserts placed inside the cylinder block of an engine. Their main function is to provide a durable, wear-resistant surface for the piston to move against during combustion. They protect the cylinder walls from direct contact with the piston and piston rings, reducing wear and extending engine life. Cylinder liners are especially useful in engines where the cylinder block is made from softer materials like aluminum. They also allow for easier repairs. When a liner is worn or damaged, it can be replaced without replacing the entire engine block. There are two main types: wet liners and dry liners. Wet liners, which are surrounded by engine coolant and provide excellent heat transfer and improve cooling efficiency. Dry liners, on the other hand, are pressed tightly into the cylinder block and do not come in direct contact with coolant. They rely on the surrounding metal of the block to transfer heat away from the combustion area. The piston is a key moving component inside the engine's cylinder. It plays a crucial role in the combustion process. It is a cylindrical part made of lightweight, heat-resistant metal, usually cast iron or aluminum alloy, and it moves up and down within the cylinder during engine operation. The piston's motion is driven by the force of combustion. When the air-fuel mixture ignites, the explosion pushes the piston downward, creating mechanical energy. The piston is connected to the connecting rod, which in turn rotates the crankshaft, converting the piston's reciprocating motion into rotational force that powers the vehicle. The highest position the piston reaches is called the top dead center, while the lowest position it reaches is called the bottom dead center. To ensure a tight seal and minimize friction, the piston has several rings around its outer surface. These rings maintain compression, reduce oil leakage, and allow smooth movement within the cylinder. The piston is usually small in diameter than the bore of the cylinder. The space between the piston and cylinder wall is called the piston clearance, which provides a space for lubricant between the piston and cylinder wall to reduce friction. Piston clearance is usually 0.025 mm to 0.1 mm. Piston rings are small, circular metal bands fitted into grooves around the outer surface of a piston. They form a tight seal between the piston and the cylinder wall, and they perform three essential functions in an internal combustion engine. First, they seal the combustion chamber, preventing the high-pressure gases from leaking past the piston during the power stroke. Second, they regulate oil control by scraping excess engine oil from the cylinder walls and returning it to the oil pan, preventing oil from entering the combustion chamber and burning. Third, they help transfer heat from the piston to the cylinder wall, which helps in cooling the piston during operation. There are two types of piston rings: the compression ring and the oil control ring. About 2 to 4 compression rings are fitted to the piston, while 1 to 2 oil control rings are fitted to the piston. The piston pin, also called the gudgeon pin or wrist pin, is a hardened steel shaft that connects the piston to the connecting rod. It passes through a hole in the piston, called the piston boss, and through the small end of the connecting rod, allowing the piston to pivot smoothly as it moves up and down during the engine cycle. The piston pin must be strong and heat-resistant because it endures constant stress and high temperatures during the combustion process. There are 3 main types of piston pins: the set-screw piston pin, which is fastened to the piston by a set screw; semi-floating piston pin, which is fastened to the connecting rod by a clamp screw; fully floating piston pin, the pin floats in both piston boxes and the small end of the connecting rod. It is prevented from coming in contact with the cylinder wall by 2 circlips. The crankshaft is a major rotating component of an internal combustion engine that converts the reciprocating motion of the pistons into rotational motion that powers the vehicle's drivetrain. It sits at the bottom of the engine block, supported by main bearings. It's made from forged steel or cast iron. The crankshaft must handle extreme forces, heat, and high-speed rotation without failure, and is connected to each piston via connecting rods. As each piston is pushed down by combustion, the connecting rod turns the crankshaft, creating continuous rotation. The crankshaft has crank pins, journals, for each connecting rod, counterweights to balance the forces of moving parts, and oil passages to keep it lubricated. At one end of the crankshaft, a flywheel or flex plate is attached to help smooth out power delivery and maintain engine momentum. At the other end, it has a crank pulley to drive belts for accessories like the alternator or water pump, and a gear that drives the camshaft. The camshaft is a rotating shaft in an internal combustion engine that controls the opening and closing of the intake and exhaust valves. It is equipped with specially shaped lobes, called cams, which push against valve lifters or rocker arms to open the valves at precise moments during the engine's cycle. When the cam lobe rotates away, the valve closes with the help of a spring. The timing of the camshaft is crucial. It must be synchronized with the crankshaft to ensure that each valve opens and closes at the correct time during the intake, compression, power, and exhaust strokes. This synchronization is achieved through any of the three types: chain drive, belt drive, and gear drive. The camshaft rotates at half the speed of the crankshaft and is made from hardened steel or cast iron. The flywheel is a heavy circular metal disc attached to the rear end of the crankshaft. Its primary function is to store and smooth out the rotational energy generated by the engine during the power stroke. Since combustion happens in bursts, the flywheel helps maintain consistent engine rotation by using its mass to keep the crankshaft spinning steadily between power strokes. Valves are mechanical components that control the flow of air into and out of the combustion chamber. They are located at the inlet and outlet of the cylinder head. There are two main types of engine valves: intake valves and exhaust valves. The intake valve opens to allow the air-fuel mixture into the cylinder, while the exhaust valve opens to let the burnt gases exit after combustion. So, that's it. Thank you for watching.